Problem 182, Classical Mechanics. The question is, the coordinate and momenta xi, pi of a particle satisfy the canonical Poisson bracket relation. The Poisson bracket of xi and pj is equal to delta ij if c1 is equal to x2 p3 plus x3 p2 and c2 is equal to x1 p2 minus x2 p1 are constant of motion, and if c3 is equal to Poisson bracket of c1 and c2 is equal to x1 p3 plus x3 p1, then we have the Poisson bracket of f and g is equal to sum over k dou f by dou qk dou g by dou pk minus dou f by dou pk dou g by dou qk. It is given that c1 is equal to x2 p3 plus x3 p2, c2 is equal to x1 p2 minus x2 p1, and c3 is equal to x1 p3 plus x3 p1. Now let us find out the Poisson bracket of c2 and c3. This is equal to sum over I dou c2 by dou xi dou c3 by dou pi minus dou c2 by dou pi dou c3 by dou xi. This is equal to dou c2 by dou x1 dou c3 by dou p1 minus dou c2 by dou p1 dou c3 by dou x1 plus dou c2 by dou x2 dou c3 by dou p2 minus dou c2 by dou p2 dou c3 by dou x2 plus dou c2 by dou x3 dou c3 by dou p3 minus dou c2 by dou p3 dou c3 by dou x3. We have c2 is equal to x1 p2 minus x2 p1, c3 is equal to x1 p3 plus x3 p1. Therefore, dou c2 by dou x1 is equal to p2, dou c3 by dou p1 is x3 minus dou c2 by dou p1 is minus x2, dou c3 by dou x1 is p3 plus dou c2 by dou x2 is minus p1, dou c3 by dou p2 is 0, dou c2 by dou p2 is minus x1, now dou c3 by dou x2 is 0, plus dou c2 by dou x3 is 0, dou c3 by dou p3 minus x1, dou c2 by dou p3 is 0, and dou c3 by dou x3 is p1. Therefore, the answer is p2 x3 plus x2 p3. That is, the Poisson bracket of c2 and c3 is equal to p2 x3 plus x2 p3. Now we have p2 x3 plus x2 p3 is c1. Therefore, the Poisson bracket of c2 and c3 is c1. Therefore, we have the first result. The Poisson bracket of c2 and c3 is c1. In the same way, let us find out the Poisson bracket of c3 and c1. The Poisson bracket of c3 and c1 is sum over I dou c3 by dou xi dou c1 by dou pi minus dou c3 by dou pi dou c1 by dou xi. Now let us expand the terms. That is equal to dou c3 by dou x1 dou c1 by dou p1 minus dou c3 by dou p1 dou c1 by dou x1 plus dou c3 by dou x2 dou c1 by dou p2 minus dou c3 by dou p2 dou c1 by dou x2 plus dou c3 by dou x3 dou c1 by dou p3 minus dou c3 by dou p3 dou c1 by dou x3. Now let us find out these terms. Dou c3 by dou x1 is p3, dou c1 by dou p1 0 minus dou c3 by dou p1 x3 dou c1 by dou x1 is 0 plus dou c3 by dou x2 dou c3 by dou x2 is 0 into dou c1 by dou p2 is x3 minus dou c3 by dou p2 is 0 into dou c1 by dou x2 is p3 plus dou c3 by dou x3 is p1 dou C1 by dou P3 is x2 minus dou C3 by dou P3 x1, dou C1 by dou x3 is P2. That is, the Poisson bracket of C3 and C1 is P1 x2 minus x1 P2. That is, we have the Poisson bracket of C3 and C1 is P1 x2 minus x1 P2. Now we have P1 x2 minus x1 P2 is minus C2. Minus C2. That is, the Poisson bracket of C3 and C1 is minus C2. Therefore, from the result, we can say that option D is the right option.